Our first talk is by David Rabouin from CNRS, and he will speak on Leibniz as inventor of conceptual mathematics with a question mark.
Yeah, the question mark is very important. So, yes. Thank you very much. Thank you for the organizer for this invitation. In fact, I should apologize because I sent my abstract a long time ago, and then seeing the program and the topic of the day, I thought it will be interesting to talk about the open issues and challenges in the edition of the archive, Leibniz archive. So half of my talk will not be about this, and this will be a case study, a little bit like what Vincenzo presented to you. So the talk will have two parts, and let's hope I can reach the second part. Fortunately, I can go quick on the first part of the beginning of the talk because Vincenzo already told you many things about this. Just quick recap. So one big problem with Leibniz is a gigantic narlas because he wrote in a lot of domains and topics, and only for mathematics we have 17,000 folios to edit. And amongst these 17,000 folios, 6,000 are text, mainly drafts and notes, oftentimes very difficult to decipher. If you just text, I will talk only about this text and not about the correspondence, which is easier to edit. If you look at this text, only half of it has been edited yet. So that means half of Leibniz mathematical manuscripts are not published today. And only half of this half according to scientific standards. So oftentimes we have like old editions which are not reliable. Gerhardt is a very good example of this. So as Vincenzo told you, this represents 8 volumes in the Academy Ausgabe, which is already something like 6,000 pages. That gives you a ratio 1 folio for equals 4 pages when it's printed. And as Vincenzo told you, 30 volumes are planned. So in Paris, we have a project right now, which is called the Filium Project. And our goal is to better assess Leibniz thought through a study of his unpublished mathematical manuscripts. Okay, so I will talk about this. What does a mathematical manuscript from Leibniz look like? Something like this. Okay, you already saw some of them. This is the one in which he introduced the sign for integrals and for derivative. Okay, and this is the one in which he introduced binary arithmetics. But oftentimes, they are not as clean as these two ones. So these ones are clean manuscripts. Most of the times, they are like this, and they are very difficult to edit for the same reason than Newton's manuscript. So here you have a typical example, and I will talk a lot about this text. On this side, you have another hand. So this is a draft that was copied, was an amanuensis, not of Leibniz, but of another person. And then Leibniz made some correction. You see like the small blue square. And then finally he changed his mind and he just erased the whole beginning that he first wrote. We have the draft. We have the draft from Leibniz. And he wrote again, and then he changed his mind, and he changed and changed and changed. So you have like 4 or 5 layers. And it's very difficult to publish in paper simply because the critical apparatus is bigger than the text. As simple as that. And this is not the worst. So we have like text like this in which he makes a lot of correction. And when you look in the detail of it, it is trying to set some axioms. And for example, you take axiom 5 and you will realize that you have 5 or 6 versions of axiom 5. So it's a nightmare because which is the first one, the second one, the third one. You have to reconstitute all of this. You have to decide how to edit them, and so forth and so on. Okay, so I will try to present in the first part of the talk some challenges in the editions of Leibniz Mathematical Archive. And in my own practice, it's taken from my own experience, we encounter 4 main challenges. And all of them, I will talk only about the new challenges. These new challenges are related to the digital tools that we try to use. So I have identified 4 challenges. One related to the question of HTR and written text recognition, and especially of the question of how to recognize mathematical formula. It's a big challenge today. There is a challenge with tables and diagrams for the same reason. There is a challenge related to mathematical symbols. And there is a challenge related to the genetic edition of manuscripts. So I have put the collaborations that are involved in all of these projects right now. So when you have a gigantic NARLAS like this, a natural move today is go to HTR. Try to make it done by a machine, okay? So this is what we have tried to do, and we are using a platform which is hosted in France, Scriptorium, and please use it if you want to do HTR. It's completely open and free, contrary to many other tools. And we fed the machine with a corpus of text. And here is an example. So you just fed the machine with the corpus of text. You need to have good quality scans. And as Scott has told you, many of the things that we are talking today were not possible just 20 years ago, simply because we had no good quality scan or even no access to the digitalization of the manuscript. And here is an example which is related to the corpus that Vincenzo talked to you about, because we tested this, we trained the model. It was already trained by our colleagues in the Leibniz archive in Berlin, but not the one in Hanover, the one in Berlin. But we tested the model with the corpus of analysis situs. Okay. And the result is quite good. As you can see, we have like a transcription which is accurate at 92%. So it's considered to be good accuracy. And then you can export it as a text. And it's like a puzzle, then you just have to put the line in the good order. So we have to train the model so that it recognizes the line, it doesn't cut the line, and so forth. And so it's a work in progress. But at least it's a nice help. Now, when you do this, you have big challenges arriving when you work on math. And so it's for everybody in the room, not only for Leibniz scholars. The first challenge is that it does not recognize diagrams. You can see, you have an empty space. It does not recognize formulas, so that's a big challenge when you're editing math. And it does not recognize tables, okay? So tables, I will be very quick about this challenge. Nobody knows how to recognize this type of objects right now, simply because it's really very difficult if you have various type of tables to train a machine to recognize the setup of a table. And even to edit them in a proper way is a very, very difficult challenge today. Okay. So, and this, I will not talk about it, but we would like to make some progress on this issue. And if you have some way to deal with this, or if you have tried this on your corpus, please give us some tools, because what we want is not a picture of a table, okay? Many people will tell you, okay, it's easy. I use LaTeX, I use this, and I can reproduce, I can mimic the table. We want the semantic content of the table, okay? Or else we know how to do it, okay? We want to have access to the data attached to this object. It's organized in a certain way, and I want to make some research to recognize other two objects in the same, which have the same structure. And this is where the difficulty begins. We have no clues. So on this, it's an open issue. Nobody knows how to do it, at least the people I talk to. If somebody knows, please send us some tools. For diagrams, we were lucky enough that two programs in France, exactly at the same moment that our programs, dedicated their project to the automatic recognition of diagrams. One is the project launched by Mathieu Husson on astronomical diagrams. And he had a project on astronomical tables, but he cannot recognize all tables. And the other one is the one which is headed by Alexandre Guibaud, which is called VHS. So that's a good news for us. They're doing the job. So we are just waiting for the result. And they're having some progress. So just to tell you, some people are working on the automatic recognition of diagrams. And once again, the challenge is not to build a picture, because a picture of diagram is very easy. It's to recover the semantic content of the diagram. And typically what Mathieu wants to do and what Alexandre wants to do is to do some search in corpus to say this diagram is the same than this one. Okay? And that you cannot do with a simple picture. You need the metadata attached to the picture. When it comes to mathematical formulae, there is nothing. Okay, there is no tool existing, so this we decided to do. So we launched a program with a guy who is a specialist into the Harold Moucher in Polytech Nantes. We launched a program to detect, segment, and maybe one day recognize mathematical formula using visual recognition and artificial intelligence. It's the very beginning of the program, but we already have some results. And how is it that we don't have good tools to do this? For example, Harold Moucher is a specialist in the recognition of unwritten equation. So how is it that he cannot deal with our text? He cannot deal with our text because nowadays the recognition of mathematical equation is based on the motion of the hand. Okay. And so I told him, okay, it's easy to go from the motion of the hand to the static text. I said, no. Because when you have a 2 in a page, how do you know if the 2 is attached to an x below, to an x above, or is a 2? And with the motion of the hand, I have this for free, x to the power 2, x index 2. It's very interesting, but very deceiving for us. So we launched a program, and we are assembling. So the first step in this type of program is to define the classes of objects that you want to recognize. We did this with Jan van Lien. We have some results, and we can recognize, we can detect. We cannot recognize, we can detect some objects in a pages like structure formulas, this type of object, or this type of object. So we define these classes. So we have some results in the segmentation and detection, but not in the recognition. So the only thing that the machine can tell you is here there is a formula, here there is this type of formula, here this, which is already a nice step, but then we want to go further and recognize the content. So these are some of the open issues in my domain, and we are trying to working and make some progress. One challenge that we must not be forgotten is, and I want to mention this because it's very important, is the ecological cost of this play with artificial intelligence. So we're also working with colleagues to build like enormous model, because paradoxically, enormous HTR model will save some energy, simply because you don't need to have everybody training his model in his corner. So this is very new. It started 3 weeks ago. So now, if we succeed in doing this recognition of mathematical equation, we can merge it with the tool of HCR, and we will be able to train some model for the recognition of mathematical documents for everybody here. Okay, if we can do this. So encourage us. And I hope we can provide some result at the end of the project. Anyway, if we succeed to do this, we will still have another problem that I want to mention, is that you can recognize the formula, but then you need to export it into a format. But if you want to export it into a format, you need to have a catalog of the mathematical symbols. And for Leibniz, most of them are not in the existing catalog, in any font, anywhere. Once again, it's very easy to do a picture of a symbol, but this is not what we want to do. We don't want to use metafont or whatever. We don't want just to do design So we launch a project, and once again, that might be interesting for all the people working in early modern math, a crazy project. We sent to Unicode a proposal for a Leibniz font. Okay, so this is an ongoing project. It's a very political question. We need to do a lot of diplomacy to convince them to create a font. If we succeed, so we're in the middle, we passed the first step, but there are many steps in front of us. If we succeed, there will be a font that you can use in your computer with old early modern symbols, and that's very useful because Leibniz used like all the symbols that he knew. He created some, but he used the symbol of Ariot, of Utrecht, of all of these people. So that might be very useful. So we have a list. It's a very long process. You first need to make a list, which it will not be complete. It's almost impossible. So at the moment, we have over 250 symbols which are proper to Leibniz. If the symbols already exist in Unicode, the proposal is refused for this symbol. It's a rule. So that means that we have 250 symbols that do not exist today in your font, okay? So this is another challenge and open issue. And then the last challenge that I want to mention is the question of the genetic edition of manuscripts. That is to say, this is related to what was presented already when you have to deal with Newton's manuscript. How do you present the layers of correction? How do you present the fact that you have several hands? All of this. On paper, it's very difficult. Or for example, the example that was taken by Vincenzo. How do you represent the fact that you have several erasures? If you put it in the critical apparatus, you really need to be an expert to decipher what is going on. On a computer, it seems very easy. I have a text, I make the erasure appearing, I have a pop-up saying it was replaced by this, and I make another pop-up saying, and then it changes mind and it repeats. It sounds easy, it's not easy. And in fact, many of the challenges here come down to the fact that digital tools are not conceived for scientific text and are not able to handle properly mathematical formulae, and neither can they deal properly with diagrams and tables. And you have a very, very simple first problem that arrives, which is the compatibility between TEI, which is nowadays one of the languages which is used for digital edition, and LaTeX. It's a real big problem because, so this is something we work with Emilou, who's here. And the problem nowadays is that TEI handles with formulas as a black box. It calls for a black box in LaTeX, which is a picture. Once again, no semantic content. I cannot indicate an erasure in a formula in TI nowadays. So we are working with Emilou and Candice Lecoffre right now on this question. And the problem, once again, is really that you want a preservation of the semantic content of what you are transcribing. Then, of course, there is also the problem of how to make the several layers in complicated cases appear. So this is a project that is done with a CNRS platform which is called Eman. And David Rabouin has a project with Eman too, and Emilou Hafner also. And this platform allows you to do this kind of transcription in which you can make the layer appear. It's not very satisfying. I would like to have it as pop-up, so we're working on it. But it's just a question of, let's say, web design. And now we have to handle the problem of the compatibility with TI. And Emilou, Candice, and Maria Laura Cucinello provided some guidelines to do this. That is to say, what will be the syntax to mix TEI and LaTeX together so that we have the semantic content like this arriving inside of the LaTeX formula. And then Candice is building a script that will allow you to read only what you want to have the LaTeX appearing as image. Okay, so at least we have the semantic content. Okay, so that was the first part of the talk. And finally, I'm not so bad. And now I can, so that are, according to my own experience, some of the open issues and challenges in the editing of a mathematical archive. When you want to use the digital tools, we have a lot of obstacles. And in fact, I have to say, I was very surprised by all of these obstacles. I thought we were more advanced. The community was more advanced. When you discuss with people working in medieval history, even medieval history of science, but this is not the same problems that they have, or when you discuss with people working in the history of music, they have way more tools than we do. So we need to be conscious that we are late and that we need to work on these tools because some of them are very useful. So what I want to do in the second part of the talk is to present you a case study which is based on the role of identicals in Leibniz's mathematical practice and in his philosophy. What is the relation with the first part of the talk? Precisely, this text that I presented to you is a typical text in which you can see something which is quite typical of Leibniz, that is, and what he called the reduction to identity. And it's related to the fact that in this text you have quite formal proof, and these formal proofs are very original for the time. You cannot find this in other authors of the time. So there are formal proof of basic algebraic statements by appeal to definition and axiom. And when you look at the only axiom that he needs is A equals A. Okay? And it's quite typical of something that Leibniz says oftentimes, that is to say, all of mathematics can be reduced to A equals A. Okay? And what I want to show to you is when you, so it sounds crazy. Okay? It sounds logicist, as Vincenzo said. What I want to show to you is that it's not crazy, it's not logicist at all, although people believed it was, because we have to look at what it means really in the practice, and for this, the study of the mathematical archive helps you a lot. So here is the typical example. It's taken from the correspondence with Clark. And by the way, we always say the correspondence between Leibniz and Clark, but we should say the correspondence between Leibniz, Caroline, and Clark, because Princess Caroline was the real interlocutor in this story. Anyway, it's a parenthesis. This is a typical claim by Leibniz, maybe one of the most caricatural. The great foundation of mathematics is the principle of contradiction or identity, that is, that a proposition cannot be true and false at the same time, and that therefore A is A and cannot be not A. Okay? And you have this all the time, everywhere. Leibniz says that all the time. You can reduce all of mathematics to A is A. This kind of claim were used by the logicists as a testimony that Leibniz was their grandfather, for sure. And the typical example of this is that they took this passage from Les Nouveaux Essais, in which Leibniz demonstrates that 2 plus 2 equals 4, by putting as axiom the fact that you can substitute equals for equals in an equality, okay? And this example was supposed to provide a typical example of somebody who believes that any mathematical statement can be reduced to a logical truth, which is the principle of substitution for equality in that case. And this claim was made explicitly by Frege at the beginning of the Grundlagen. He explains that all these people following Kant are completely wrong. Mathematical statements are analytic, they are based on logic, and the only person who saw that is Leibniz. And he copies the demonstration, and he puts an asterisk, and he says, and this axiom can be transformed into a definition. I think he says that here. Yeah. And here he refers to a passage in the logical calculi from Leibniz. I will show you this passage. And he talks about this a little bit later. And this passage is this famous one. Things are the same as each other, of which one can be substituted for the other without lot of truth. So this is what is now called Leibniz law in logic. That is to say that two things are logically equivalent if and only if you can substitute one for the other by preserving the truth, salva veritate. Okay? And you can see, this is what Frege explained, that in fact what he says for equality is just a specification of the predicate on which the substitution work. So this is the logicist picture of Leibniz. It is based on text that I showed to you, based in algebra, text in algebra, text in arithmetic. As soon as this was proposed, there were objections. There were objections to this picture. And I have to mention this. And for example, people like Brunswick says, no, it's completely wrong. You didn't look at Leibniz mathematical practice. Leibniz mathematical practice is not based on this. You just took a few texts, and it's not based on this. And in fact, you're confusing an ideal with the reality of his practice, okay? So this is something that you will hear again and again. And in fact, in the last 30 years, that was the motto for many historians and philosophy of math working on Leibniz. They say, okay, it's true that he says that, but in the reality, in the practice, this is not the way he's doing mathematics. And I find it a very weak answer. It's a very weak answer because even if he didn't do it, he said it. So you're not answering the fact that it sounds crazy. You're not absolutely, I mean, the only thing you are saying is that he was not able to do it. And in fact, Frege and Russell acknowledge this. He was not able to do it, but they say, but we can. So in fact, they are simply right when they say it was their grandfather. You're just saying, okay, this is not a good. So what I want to show to you is that neither of these people are right. And precisely because the reduction to identical is a mathematical practice, but this reduction to identical doesn't mean the reductions to the law of identity. This is what I want to show to you, okay? It's a mathematical practice, and this you can see when you look at the manuscript. So one difficulty when you have 6,000 folios to study, oftentimes without identification of dates, we talk about this with Newton. For Leibniz, we have, most of the time we don't have dates on them, is simply to group them and to identify the relationship. So that has echoes with what Nicolo has presented this morning. For a long time, and this is the practice that was done by Whiteside, but this is also the practice that was done by Gerhardt and by Couturat, the main tool in order to perform this task was the conceptual analysis of the text in connection with the context when it was known. Okay. An additional tool that was presented by Vincenzo is the watermark. But the watermark presents you a terminus a quo when he bought the paper. And sometimes it can be like 40 years before. You have to be careful. I mean, we don't know. So that's why Vincenzo says, yes, and we know that he wrote in a paper just after that was not used, and so forth and so on. You need more than just the watermark. And in fact, many mistakes were based on the fact that people took the watermark for granted. So concerning our topic, the reduction to identical, this led to a very widespread picture. The archetype of the reductions to identity is provided by proof like 2 + 2 = 4, that is to say by arithmetic, and by formal proof of basic algebraic statements, such as the one that I showed to you in this text, which is called Prima Calculi Magnitudinum Elementa. So the conceptual progression, which was supposed to be the historical progression, should be something like, first he did some axiomatization of arithmetic and basic algebra. Then he generalized into a more universal theory that he called Mathesis Universalis, or universal mathematics. Then he generalized to logical calculi. And then that was his project of a Characteristica Universalis in a way, realized, okay? So that was the basic reconstruction that was in every mind for a long time. You have it in Couturat, just by looking at the table of content. But if you look, for example, at Wolfgang Lenzen's paper, Wolfgang Lenzen is a specialist of Leibniz logic nowadays. He has exactly the same picture. He's claiming that Leibniz generalized what you have found in arithmetic and in algebra into logical calculi. Okay, that sounds reasonable. Okay. Fortunately for me, I was able to date precisely the text that I showed to you, the Prima Calculi Magnitudinum Elementa. And this is a way to date Leibniz's paper, is when you find a letter that mentioned them. Okay. And I found this, I was working on the manuscript, and I saw that in one text, one letter that was sent by Rudolf Christian Wagner. So Rudolf Christian Wagner was Leibniz's secretary. Okay? And at the time he was in Untitled. I will not explain why. And he says, okay, in the second page, under the number 24, you should erase this word. Okay? And here you have a note from the editors who says, oh, this is part of a project of Mathesis Universalis, which is my main topic of study, but they could not identify it. Okay. And they could not identify it because the paper is not named Mathesis Universalis, but I could identify the paper because I'm working on manuscript. Okay, if you look in Gerhardt, exactly like Whiteside, he does not mention, when there is a mistake, he corrects the mistake. Of course. So here we can see that Leibniz changed his mind, he put this at the beginning of the sentence and he forgot to raise it at the end. And so Wagner is saying, and this is number 24 on the page 2. So no doubt. So I have a date. But this date is very surprising. It's 99. It's not the beginning of Leibniz's career. You remember what I told you? First, he axiomatized arithmetic and algebra, then he moved to Mathesis Universalis, then he moved to logical calculi. And 99 is 10 years after the big logical calculi, which are in 85, 86. Okay? So it's the other way around. It did not work the way that... So step by step, we were able to identify all the text dealing with the algebra, the axiomatization of algebra, and they are all after the one I mentioned. And they are co-occurring. By the way, it might allow you to produce this type of graph automatically, so it's very helpful. You just have to indicate the dates and the relationship, and it shows you the corpus. All of these texts are after 98, okay? So why is it surprising? On the one hand, Leibniz always said that he got the idea of that all mathematics is reducible to identicals very early, even when he was a boy, he said. And we have documents even before Paris, that is to say even before 72, testifying that it was the case. We have some proof in which he reduced to identicals, okay? So we know it's an old project. It's true. On the other hand, we just saw that the axiomatization of arithmetic and algebra is late, very late, okay? It's more than 20 years after Paris, more than 10 years after the logical calculus. It's 15 years before his death, okay? And so the big question is, if it does not work in this way, where does it come from? What is the source of all of this? Okay. And in fact, it's not difficult, thanks to the progressive edition of Leibniz's mathematical manuscript, it's not difficult to identify the origin of this type of reduction, of this practice of reductions to identicals is to be found in this type of text. Okay? Very clearly, here you have a definition of the equality by the substitution salva magnitudine. At the time, it's a definition that you can transform into an axiom. For Leibniz, it's not a problem. He explains that. And on this base, he gives formal derivation, although not algebraic at all, formal derivation of some properties of axiom like the transitivity of equality. And for him, it's very important because what he's doing is proving Euclid's axiom, Euclid's common notion. He's showing that all of Euclid's common notion can be reduced to only A equal A. Okay, to the equality of something itself. So this is very interesting because the context here is not the axiomatization of arithmetic of algebra. It's not analysis situs properly said. And in fact, these texts were edited in the philosophical paper. Strangely enough. Okay. And when you look closely, you see that in fact it was a systematic approach. What Leibniz did is to identify some basic, so we will call them today's equivalence relations, okay? He will identify some basic equivalence relation by kinds of substitution salva something, and this will give him the basic mathematical object that he needs to deal with. So we talk about congruence for the situs. You need to have similitude to have form. You need to have equality to have magnitude. Okay? So he's explaining that any mathematical object is introduced, it's very close to what will be called later a principle of abstraction. Any mathematical object is introduced as the name of something which is preserved by an equivalence relation and a substitution. Okay? Not only that, but the very important, there is not one. There is not one. There are several identicals. Okay? It's very important to notice this. And in fact, as you can see, when Leibniz talks about the identical, he talks about of them in plural form. In fact, the correspondence with Lark is quite an exception. Most of the times, he's talking about the reductions to identities or to identicals. Okay? And you have a list in which you have similitude, you have even the order relation, because according to him, order relation can be expressed through equality as a negation of equality, and so forth and so on. So this is something which is very interesting. And what is the meaning of A is A for Leibniz? A is A for Leibniz is not a logical principle in that case. It expresses the reflexivity of this relation. And it's very clear if you read the quote that I'm explaining. So according to Leibniz, you need two things, reflexivity and substitution, and then you can demonstrate all of the properties of any equivalence relation. And this is true. This is true. If you have substitutivity and reflexivity, it's enough. And he sees that. And so, for example, this is a French translation of a paper on analysis situs. He classifies and he says all of these identicals are transitive. All of them. He has a symbol for similitude, a symbol for congruence, a symbol for equality. And he says, so the reduction to identities should be seen as a practice. and a way to organize the mathematical object, and it's based on not one relations, but many identicals, and Leibniz then tried to classify them, and he has no final answer to this question. Not only that, but he reached at some point even very, very abstract presentation in which you will derive what is the properties of an identity in general. And we have this text, for example, which is very interesting, which is based on the relation of discernibility. And you have... So there are numerous texts of this sort in the period between 75 and 76 and 85 and 86. And what is striking is that they belong neither to geometrical calculi nor to logical calculi. They do contain no operation. So they are not calculi in the sense of Leibniz. Okay? What they contain is what Leibniz called the analysis notionum of mathematics. And I propose to translate this as conceptual analysis of mathematics, hence my title, with the question mark. Okay? In short, Leibniz developed a practice in which conceptual analysis is seen as a proper tool for the discovery of new mathematical theories and new mathematical objects. And one can show that this is the way it proceeds in order to build his various calculi. Okay. And you can show, for example, that this is the way that he built the logical calculi, okay, on this basis. So if you're interested, a little bit of advertisement. This is explained in all detail in my book, which should appear in a few weeks. And in fact, he has a name for this. He called this the Scientia Generalis, not the Characteristica Universalis. And he explained that he found axioms for many, like coincidence, congruence, similitude, determinations, which is like for us functional application, and relations in general. Okay, so he's building a conceptual analysis of relation in general in mathematics. Okay, so in fact, I went way quicker than I thought. So I'm done with it. And so we have many times to discuss. So this is what I wanted to present to you. That is to say that, oh no, I should summarize the conclusion. So please take this away. When we talk about the reduction to identity and the logicism of Leibniz, we should keep in mind that what Leibniz says more properly is that all of mathematics can be reduced to identicals. So please take this with you. And when you look carefully at what it means is that conceptual analysis is a crucial tool in mathematics, and it's based on the role of substitution. Okay? It's based on the role of substitution. If you want to do a calculus, you need to have substitution. But you have many ways to introduce substitution, and that will correspond to many ways to introduce identities. And on this, and sometimes you can mix various. It's not like one identical corresponds to one calculi. It's not like this. You can have several. Like for example, in analysis, you have congruence, similitude, coincidence. No problem. And the question is how you will relate one. And so I claim that Leibniz invented a way to do mathematics, which is based on conceptual analysis. Of course, many people were analyzing concepts before Leibniz, but what he's saying, and I think showing, is that conceptual analysis is a way to invent new mathematics. And that's very original. That's very original. And hence my title, I propose that Leibniz might be called cum grano salis, since we don't know exactly what conceptual mathematics here is, and there are many debates, historiographical debate about this category. I'm aware of this, but I introduce this little complexity in the debate by saying that Leibniz might be the inventor of conceptual mathematics. Thank you for your attention. This is a little drawing by Leibniz when he was bored, doing calculation like everybody.
Fantastic, thank you so much. So we have some time for questions. I don't know if there's one here from Karen.
Yeah, thanks a lot. I'm not sure I could follow everything because it's so new to me, but something struck me in what you have said. I mean, I have lots of questions, but what about the sign of equality?
Mm-hmm.
Because what you are saying is A is the statement you said of reflexivity. But do you have different signs for equality?
Hmm? Okay, so we should not call it equality, we should call it identities. Okay?
Yeah, but I suppose that when he does computation,
Oh,
When
yeah,
he does computation, he has the sign for equality.
absolutely.
And
For-
so,
yeah. And do you have other signs? Yes. And can you, for example, write a similitude between algebraic formulas? You can. And you use another sign that the equality, which means the equality of magnitude. So, for example, when Leibniz want to, when you want to do the method of indeterminate coefficient, what you're doing is to say that two equations have the same coefficient one by one. Leibniz has a sign for this. He says that the two equations are similar, but they are not equal, and he used this sign in this specific case. And he will introduce many signs like this. Many signs like this, so you have, I don't know if it answers your question, but he has different signs to express this. They are not equalities in this sense, because in this sense, equality is strictly for magnitudes, for the equality of magnitudes. But there are equalities in the logical sense. Yeah. Does it answer your question?
yeah, so, I mean, now, for instance, you have given the example. I mean, these are other questions I don't want to monopolize. Since I saw that nobody was raising a hand, I just jumped in. But, so, in your answer, you said there is a sign that is like a kind of identity between two formulas.
Mm-hmm.
But for instance, you said you have everything that you can substitute for something else makes a kind of object, a kind of identity.
Yeah. Mm-hmm.
And hence, I was wondering whether you distinguish, if you want to compute with these things, and if you want to say that they are equal, do you distinguish different signs for equality?
Yeah, you have to. And the example I gave is a very good example. So Leibniz introduced a definition of similitude for geometry. He was very, in fact, he did not introduce it for geometry, but he found a definition for geometry of which he was very satisfied. But he used it already for combinatorial forms, okay, for the identity of combinatorial forms. And his idea is that you could use it in algebra. And so then, in some text, he will say, each time I have a similitude, which is, I introduce an object which is the form, okay, the form. So I can use it for equation, and there is a precise meaning of the form of an equation, which is related to what I said, the identification of the coefficient, and not the equality, the numerical equality of the two objects, which hold, by the way, 2, but I don't look at this. So in the text, he will separate one sign for equality and numerical equality, one sign for the similitude, and then he will compute some kind of combinatorial properties of equation based on this. And for this, as you know, he will use his method of fictive numbers and all the things that were studied by Eberhard Knobler, and you will put them into tables, which is not the same kind of computation that you do for basic algebra, but exactly will do what you're saying. And so you will have on one side the computation with the sign of equality, and on the other side the tabular forms that represent the identities of form, of equation, and the manipulation of the so this we have, yeah. Yes.
Could I ask a question?
Sure.
So you're talking about, you've got reflexivity, you've got transitivity, symmetry.
So symmetry is proved.
Okay.
Symmetry is proved. I could have shown the translation.
So he asserts the reflexive property.
Yeah, you need to assert the reflexivity. You need to assert the reflexive property, and with substitutivity, you can prove the other properties of equivalence relation.
Prove.
By substitution.
Okay.
By substitution. If you have A equal A, and if each time two things are equal, I can substitute. You will substitute in the transitivity. You substitute in the middle, and in the symmetry, you need to write it twice and substitute on each side, and that will work.
Okay.
Yeah? No, I mean it's true. I mean what he found is true. I mean it's not something which is crazy. Nowadays you can still, if you use natural deduction tools, you can just introduce equivalence relation with reflexivity and substitution, and then you demonstrate the other property. We are not used to this way of doing because we do it in a set theoretical setting in which we prefer to describe all the relation by their distinctive properties, but it works. And he found it.
Question here.
I have an extremely easy one and a wildly speculative one. Easy one. Would you go back to the slide with your book on it so I can write down the title?
Yeah, sure.
Wildly speculative one. In the first half of your talk-ish, you were talking about being a tool builder, and this building of the tool for recognizing handwriting and tables and diagrams and whatnot. You're starting to think about ecological things. What I'd like you to speculate on, if you're willing, a little bit is the ethics. I'm thinking about the second half of your talk, where you're able to identify certain sources because of your deep familiarity with manuscripts and your struggle with transcription. Imagine a world in which you're successful. You have an OCR system that scans any mathematical text. No one will ever fund an editorial project again, and libraries batch digitize and they put it into a text thing. How does that change our world, our knowledge, and where do you think of yourself in the ethic of tool building in that?
Yeah, no, it's a very good question. Now, of course, we are, I mean, the community working on this is very much thinking about this, but we are not so afraid, since this problem is a real deep general problem in which we are like a drop on the ocean, and we are so very far from having successful tool that we will be so happy to have the first step in this, which are billions of years from what you're expecting. That is to say, just to have recognitions for static mathematical formula will be a huge help. And it's not a question of asking any analysis by the computer at all. It's just a question of transcribing. I mean, I am the one who deals with the text transcribed. I have to reorder the line, I have to do this. And nobody has any cues, even for HTR, nobody has any cues of a machine doing this. No, nothing. So, I mean, you're right, it's like the ecological question. We talk about this, we raise some question about, and the question of openness and all of these are very important questions. So there are many ethical questions involved, but we are not very, I have to admit, we are not very stressed by this concern because it's so far away from us. It's very, many people, I mean, in medicine and so forth and so on, are closer to this problem, like right now. But we are, they will encounter this question, they are encountering these questions before us, and we hope they will define some guidelines. I mean, I discuss with them too, they are part of the community, but we are very, 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 very far from this, very far. Yeah.
You mentioned in the first part of your talk that compared to scholars of medieval manuscripts or music, we are very far behind.
Yeah.
What are some of the tools that they have that we don't?
They have TI.
And
they have TI. They have a TI for music. And when we ask the TI community with Emilou, can you do the same for math? They say no. They say no. I mean, we have two to ask. If we are 100 to ask, maybe we will have it. But they don't build tools for two people. So there is no language with metadata and the semantic content for math, for editing math. And even TI is not very well designed for the type of manuscript that we are dealing with, because we are forced to change the way it was built. It was really built for people who have an archetype, a stemma, and copyists working on this stemma. It was really created for that, and it's very clumsy for us. We are obliged to redefine the tags and to introduce new tags. So we have many, many examples. So TI is an example. And for the handwritten recognition, and for the HTR, the models that exist work very well for medieval manuscript. Period. They have a lot of models. They work very well. And for early modern, we don't have a lot of models. We have some mainly literary models in literature. And
There's a question here.
yeah.
Hi, thanks for the talk. In fact, it's very similar to what I'm working now. It's so I'm working on producing a digital edition of Newton's Principia, and I have actually a similar workflow as what you're doing with HTR stuff. So I also have a question on that part of stuff. And instead of the ethical concerns, I have a very practical question. So how do you, if I understand correctly, you have a pretty accurate model trained, which is like 92% of accuracy for the text. And also you're working on mainly improving the mathematical formula of Leibniz. So I'm just wondering, how do you tackle with the AI-generated errors in the texts?
We correct them. We correct them by hand. I mean, we have no. You mean the 8%? Not
Yes.
not. Yeah,
Like in the text correction step.
yeah. We correct.
Correct them manually.
Yeah. It's the way we are doing. We have no. I mean, I'm happy if we have other solution, but right now we have no. And I should say that the 90% accuracy is only for manuscripts that are not too messy, and so we still are improving the model. We are still training the model, and so there are many issues about this. But right now we are correcting by hand. The same. What I showed, for example, is not very satisfactory for the order of the lines. We correct this by hand. Correct this by hand.
Do you mind go back to the slide where you have the model training?
Yeah. Sorry. Like this? This?
Yeah, I think the previous one. I'm just curious which platform. Yes, this platform. So what's your general experience of using that?
First, I have no choice because I work in a European project, and my project has to be fair. Okay, and in fact, Transcribus, which is another platform, is not fair in the sense that you don't own your model except if you pay for it.
That's
So,
what I'm using. I'm using Transcribus.
Well, no, maybe, why not? But I have no choice. I'm not allowed to use a non-fair, and which in a way is good. So I'm encouraging these people. So you have, my experience is that it seems to be less ergonomic than Transcribus for many things, but it's really an open community. All the models are accessible to everybody. My colleagues in Berlin, they started with Transcribus and they lost their model. So, I mean, they saved their result, they saved their data set, but the model was interrupted by Transcribus because Transcribus owned the model. Okay, you have to keep this in mind. So we own the model. I mean, everybody owned this model. We didn't make it public because we are still training it, but as soon as it's ready, it's for all of you. Okay, and you can fine tune it. If you work on early modern, on the hand, you just need somebody who writes Latin and French, and that will that should work even for to see, because English is different, but English Latin is different than the French Latin. But well, so that's my experience, and it's a very friendly community. You can talk with them. They are very young. They are all medieval. Some people are working on early modern, so very good experience with this platform.
Okay, thank you. And one final question is, how large is your database when you use the training for the training class?
So this one is something like, I think something like 200 sheets, but they are double folios. They are double folios. Sorry. They are double folios. So that will be 400 folios. 400 folios. But we cannot have the same data set for the equation, because the ground truth is, well, I will not enter into the details. So for the mathematical equation, we have a very small data set, and we artificially enlarge it. So this, we can talk about this in the break, but there are, so we have a data set with 64 pages, but we can artificially make it as 500. If you're interested, I can tell you, I mean, except if you know already, but there are techniques to create.
Yeah, I'm very interested.
Okay.
Rob, do you have a question?
So this is a simple but nasty question.
Newtonians.
How would you measure gains in efficiency in terms of transcription?
Very good question. So,
compared to what would have happened if you hadn't?
Okay, very good question. So one day we tested the model on a group of manuscripts, and there were some mistakes, obvious mistakes, and quite a lot of mistakes on this manuscript, because you don't control on which manuscript it is good and not, because it can be a question of contrast of the background, stuff like that, that you don't see very well as a human being. Anyway, we have this result, and the people working with me, Vincent Giovanangeli, who was the research engineer, he sent it to my colleague in Hanover, and he said, hey, can you have a look? Does it look good or not? And Zygmunt Probst, my colleague, my dear colleague in Hanover, did not understand properly the question. That was not phrased very well in English. He thought he was asked to correct. So he corrected it. He corrected it completely. And so the research engineer says, hey, that's interesting. How long did it take you to correct the manuscript compared to? And Zygmunt says, so it took me 1 hour to correct, and it would have taken me 1 hour to do it from scratch. So my research engineer was like completely depressed. So he wrote to him and he says, okay, so what's the point of what we're doing? And Zygmunt answered the following answer that I find absolutely marvelous. He says, it took me 30 years to reach this 1 hour. Anybody can do what I did to correct your transcription. And this is our experience. I can take internship, and they can correct the transcription if they know Latin and they are a little bit used. So this is the gain. The gain is that we are losing some expertise. Zygmunt Probst will retire next year. We are losing expertise, unfortunately, and it's very difficult to be trained in Latin, mathematics, philology of the 17th century, as you all know. That will be the gain. The gain is that, as Vincenzo explained, the plan is 50 years of edition for Leibniz mathematical manuscript. 50 more years. So we need to think about who will do it, and I mean, okay, that's my answer.
Any final questions before we break? Karen.
I wanted to go back to the thing you translate as concept.
Yeah.
And I wanted, because if I understood correctly, when Leibniz says analysis notional, if I understood your talk, but this will be a way for me to check, what that means is identifying things for which I can find that which can be substituted for it. So somehow it's an analysis of things that are different types of identicals. Is that right?
Yeah, but it's not as if you are looking for this object. So Vincenzo gave a very nice example. If you look at the text on analysis situs, Leibniz wants to understand the term situs, okay, which is not an identity. But to understand situs, he will introduce what it means to have the same situs.
Yeah,
you see, it's a strategy.
Yeah.
Okay.
So, I mean, situs is something for which you can claim identity.
Yeah, absolutely. Yeah.
Okay? And so, the point of the analysis of notions is to identify that between which you can have identity. So, identify different kinds of identical.
Yeah. The story is a little bit more complex. Of course, you realize that there are not only equivalence relation in math. So you have to deal with order relation. He sees this. You have to deal with maps. He sees this. This is what he calls determinatio, and he will explain the compatibility between these various strata. So, but one major aspect is the identification.
I just wanted to understand in which sense it was conceptual mathematics. It's conceptual mathematics in the sense that you have identified all the kinds of identical that you can have.
Yeah, no, I would say that what I find very original is this idea to enter into math by saying we don't know what are the basic concepts. Leibniz says that oftentimes. We don't know what are the basic concepts of math. I need to find them. This is a very strange way to enter into math. And I have to find them, I have a strategy. And the strategy is the one you're saying. So I think it's richer than just this result. He has a way to see mathematics, which is, and in fact, this is what he's doing. He's creating new theories. And he insists on this. This is what he called the art of discovery. That is to say, by analyzing the basic concept, by finding new concepts, I will find new theories and new ways to solve problems and so forth and so on. So that's richer than just to, but the strategy is the one that you said, the strategy to do. But I call this a concept, I mean, it's cum grano salis, but
I wanted to measure the size of the grano.
Okay, so we're going to stop there and have a half-hour break for tea. While you're out there, if you haven't ticked off which method of communication you prefer, which is what Troy was asking us to do, that's just on a board by opposite the coffee and tea. But let's return at 4 o'clock, but let's thank David again for a wonderful talk.